So I wanted to talk a little bit about what we as humans are doing to the oceans. Now, generally, we think of this as all bad. I think there's some interesting things here that's not all bad. But speaking of bad, let's start off thinking about coral bleaching, right? This is an article from the art magazine Outside talking about the obituary for the Great Barrier Reef. It was an article that basically was talking about how it was talking like the Great Barrier Reef was already dead, and we know definitely that the coral reef is in trouble, but I wouldn't say it's absolutely dead yet. So what is coral bleaching though? Because this is one of the main things we're going to be talking about today. Corals have a symbiotic relationship with their algae called zooxanthellae. And this is mainly due to two different things, high temperature and pollution. So it can live for a short amount of time. So these are corals here, the white ones have obviously been bleached. They're going to lose out on a lot of their food because those zooxanthellae are creating the sugars for the little jellyfish that live in their calcium carbonate shells. But so they lose a decent amount of food, so they're starving basically, and they're very susceptible to disease then. And when we look at temperatures, because temperatures it's a multifactorial thing where temperature and pollution and disease can come in and wipe out a reef, but bleaching in general is mostly tied to temperature. Okay, when it gets hot, it goes away. So this GBR is Great Barrier Reef. Okay, and what we see is that in the southern hemisphere, the northern Great Barrier Reef is closer, lower latitudes, and they can deal with hotter temperatures. And then as you go down to the southern, they can't deal with hotter temperatures. These temperatures are in degrees Celsius, and above this 30 degrees, they get a bleaching event. So what we see is when we're looking here at 2020, right? These are generally this is the line of that thermal threshold, right? So when we're at 2020 here, what we're seeing is Jamaica has been above those thermal thresholds for about 20 years, right? Phuket, again for about 20 years. So we see a lot of bleaching. Tahiti has done a little bit better where, but real quickly these are climate models, we're going to be above those sea surface temperatures that are really going to create bleaching events every year. And this is what we have seen essentially in Jamaica. We have seen a bleaching event pretty much every year. This is bleaching events per decade, right? So out of 10 years, how many bleaching events do you have? And see, in the 2000s it was 9, and right now 2010 it was 10 every single year, and we're going to have it every single year. Tahiti, starting in about 2030, we're going to have a bleaching event every single year, and that's pretty much all across in any place. By about 2030, 2040, we're going to have bleaching events every year. And it just depends on how long those bleaching events last, whether the reef will survive. So what's going to happen is there's 3 scenarios that we can see. One is a strategy shift where the hardy species replace the sensitive species, right? Because you can imagine that, certain species are more susceptible to bleaching than others. Well, what about tolerance? Will the corals acclimate? And the answer is probably not. They might a little bit. Each individuals have some ability to respond to these bleaching events, but realistically, it's happening at too fast of a rate for them to acclimate evolutionarily. So what about a phase shift where corals are replaced by algae? And what we see is this is the most common thing, where corals are going away and being replaced by algae. What we see is oceans are warming right now at 2 degrees Celsius per century. 2030 is right when we see the massive bleaching events being predicted, and we're going to see massive phase shifts to that algae by shortly after that amount of time. I would probably think this will happen faster. We'll have to see. So what is this to say is if you want to go scuba diving in coral reefs, do it soon. When you think about what this phase shift to algae, what we should be really looking at is the whole interactions of going on. It's not just one specific thing. Algae is always found in these coral reefs. It's not like algae is really bad and this invasive species. It's always there, and but it's just eaten at a higher rate. So soft algae is generally, easier to digest. You don't need special adaptations. So the turtles and the herbivorous fish are going to be in there eating them, and keeping those at low levels. However, overfishing reduces those herbivores. So we've reduced our turtle, our manatee, our parrotfish, our surgeon fish populations to the turtles and the manatees are essentially ecologically extinct. Yes, we find relic populations around, but they have really no effect on their ecology because they're so low numbers. So put those two things together, you get already an abundance of algae, then the reef bleaching events, which make algae go like crazy. So Jamaica is a really interesting case study. So, and this is, a 200-year-old story or more. Before 1800, basically, the slave population, right, that was brought over from Africa is not really given any food, so they have to find their own food. And one of their main food sources then, protein sources, was sea turtles. But by 1800, all the slaves around Jamaica had used up all their turtles, and there weren't any more, right? So they switched over to their protein source for fish, and surprise, surprise, they outfish the amount of fish there. So by 1880, 85% of the fish that they're eating are imported from other places, right? By the mid-1900s, local overfishing is really common. So really what we're left with is only sea urchins is the only real ecologically relevant herbivore that's still common. Hurricane Allen came in 1980, a really big Category 5 hurricane, killed off a bunch of the sea urchins, and right then the reefs already shifted over to an algae-dominated system. So that if you go diving in Jamaica right now, what you're left with is, what you see is this, a bunch of dead reefs and a couple fish swimming by. So you might ask, well, do we really care about coral reefs other than, a pretty place to go look and scuba dive? And the answer should be overwhelming yes, right? They are huge shoreline buffers. This system here, this hotel that has, a bunch of people staying here and able to have an over-the-water resort restaurant or something here, right? The only reason they're able to be there is because of this reef. This fringing reef here is definitely protecting the shoreline, and waves crashing in if there's a storm without this reef would totally wash away this, potentially the whole beach and the whole area. Reefs are really good at protecting all sorts of different shoreline areas. In developing countries, about 25% of the total fish catch is found in reefs, and brings in millions of dollars of tourism all the time. These are looking at some off of Australia and the Great Barrier Reef, some liveaboards. These are pretty expensive ones. You can find them for much cheaper than that. But people are spending lots of money and bringing money to the local areas where these reefs are. That is really expected to go away within the next 20 to 30 years for sure. All right, another sad topic. Let's talk about plastic pollution, right? When you see pictures like this, it makes your heart ache, right? Pictures like this too. And I think, all these pictures are really, really sad and show, at least at the small scale, what the problem that we see with all the plastics that we find in the ocean. But it's a really, really big problem. Ocean plastics adsorb. That's not AB sorb, right? It's AD, which means there's chemicals that adhere to the surface of the plastics, and those can get bioaccumulated. So when organisms are eating the plastics, oftentimes they'll just eat the plastic and poop it out, especially if it's a very small particle. But those PCBs, those DDTs, those pesticides, and really bad chemicals can get taken up by their body and bioaccumulated up through the food chain due to the all the plastics in the system. I thought this was kind of funny, where may I have a plastic bag already inside that fish, right? And organisms are not don't really understand the difference, right? We can see that this is a plastic bag in the ocean, but sea turtles don't. A lot of organisms will actually preferentially go after plastic because of the way it smells to them, and it's covered in like microbes that smell different to them, and they'll actually eat it at a higher rate. When we look at the whole system, what we see is there's two really big garbage patches in the Pacific Ocean. The Atlantic has one, the Indian Ocean has one, but by far the biggest is the Pacific Ocean, because that's the biggest ocean, right? And so it has the most plastic. And because of the currents are generally going from east to west here, and then we get a spiral current here. Up north, you got a current going from west to east, which makes a bunch of plastic collect. Now, this garbage patch is like really kind of, it's diffuse, right? There's a lot of plastic out there. It's not like you can just hop from plastic piece to plastic piece. But I will say that I had some interesting experiences with this when I was in Thailand. I was scuba diving in Thailand, and we were several hundred miles away from shore on these really abandoned islands. It was insane, because wherever I was in that boat, that entire 3-day trip, I could always see one large piece of plastic, and I'm talking like the size of a person or bigger or something out there. And we were hundreds of miles away from any people, and there was just so much plastic out there, and it made me really quite sad. And as plastic is extremely persistent, right? We don't necessarily think about how persistent it is. I'm sure you've heard about it, but I think this rubber ducky spill in 1992 was really kind of interesting, where a boat was going from Hong Kong to Tacoma here, and it hit a winter storm, and one of the containers that the ship had had a bunch of rubber duckies. And you can see where all of these rubber duckies went. 29,000 rubber ducks were spilled, and 15 years later, one of them had made it all the way over to France and England, right? And these rubber duckies, they could be tracked to this one specific shipment, went all over the world much later. And so we have this huge conglomeration of plastic that isn't going away, and the pieces that are breaking up are just getting smaller and smaller, and are going to be harder to clean up. I think really the only viable way is that we need to have a huge effort to clean up this plastic. It's probably one of the bigger environmental problems that we have. I would say maybe second to, or climate change being the biggest one, land use problems being second. Maybe this could be number 3. I don't know. It's kind of depending on your opinion. But the Ocean Cleanup Project was this pretty cool project designed by a 17-year-old. I think he's from the Netherlands. I forget. Might be French. And it's a passive collection system where they've gone through a variety of different prototypes, and they've just started to get some successful results of where they're cleaning up the Pacific garbage patch. They need a lot of funding, as you can imagine, because these systems are not cheap, right? It's on average about $4.50 per kilogram removed. Okay, and if we think about how many kilograms of plastic are in the Pacific Ocean, that is insane. But it is only 3% the cost of conventional methods, and what I mean by that is that those, like basically taking a big net and dragging it through a boat. So if we look at what's actually happening here, I've got the website pulled up over here, and this is their actual system, where they have a sea anchor, a big parachute in the water, and then this system here. And if we look down, what happens is you've got the sea anchor, and then you've got the array here. And so what happens is the water is going to be flowing this way, right? And what happens is that this thing moves slower than the water around it, right? The water is pushed and the plastic is pushed into this net, and it's accumulated in this net, and this net hangs down just a couple meters. So like fish don't get really stuck in it. They're not super big, and and it is, if fish do get stuck in it, well, it's not really going to have a huge impact. Then a boat comes and will take away, clean up this and take it away. What's their expected impact is that they're expected to, if they were to have 100, I believe it's 100 of these systems, it would clean 50% of the Great Garbage Patch in just 5 years. And what they're actually wanting to do is remove 90% of the ocean plastic by 2040. Is that realistic? I don't know. I think it depends on how much funding they can get. Right now, what they're also doing is looking at rivers, right? So where is all this plastic coming from? And it's essentially, 80% of the rivers, the plastics is coming from very few rivers. It looks like 1,000 rivers is a lot, but it's really not that much. And I forgot where. So this is a map of the top polluting rivers, and what we generally see is it's in rivers that are in mainly Southeast Asia, right? That's where essentially the less developed the country is, the more river pollution, river plastics are going to be coming in. So we see China, Southeast Asia, and India are where a large portion is, but then a lot of Africa and the Central American countries too. And that's just a function of they have little money to get rid of their plastics. So I really hope this project takes off. We'll see if they can get international funding for it. All right, let's move a little bit to mercury, because mercury is something that isn't going away. It's basically created from burning coal. The more we burn coal, the more mercury we're going to be releasing. Take a look at this, and we can see that most of that mercury emissions are from fossil fuels, but this is from metal production, so this is like smelting steel. But this artisanal and small scale gold production is a really big portion of it, and that is, if you ever watch those shows, like on Discovery Channel, where they're mining for gold, and basically what they're doing is they're digging in these along streams and looking for gold. It just turns out where we generally find gold, we also find mercury in the sediments that releases a bunch of mercury into the water. Now if you look at this, this is basically how much mercury is deposited on the land. And what we see is what percentage of the mercury is actually deposits that originates outside of the US. So basically, where it's all red, this is, at least for right here, this is Chinese coal. This is Chinese mercury raining down on us. But this over here is American mercury that is raining down on the east. these are where all the people are, though, also. So what we see is, mercury is raining down on us from, we burn coal, mercury goes into the air, and it then goes in, hits on the land, and gets into our water systems. Bacteria then change it into this thing called methyl mercury. Methyl mercury is extremely toxic. Not while playing with mercury, from a thermometer is dangerous. It's the really toxic stuff is this methyl mercury, where it's impairs thinking, basically attaches to our nerves and doesn't let our nerves send impulses, and really can affect our brains, our nervous system, memory, language, fine motor skills, all sorts of things. The thing about methyl mercury is that it bioaccumulates, right? The more predatory a fish is, the more mercury you get in the system. So these are ocean fish, but also it's the same thing happens with freshwater fish. So if you look at this. This is looking at Wisconsin. So the DNR says basically they break it up into women beyond their childbearing years and men. But I think it's really interesting they talk about women of childbearing years and children. So basically, if you're going to have a baby ever, you should be thinking in this type of situation where let's just look at the women of childbearing years. So 1 meal per week of bluegill, yellow perch. I don't know who eats sunflower or bullheads, but bluegill and trout. 1 meal per month of walleye, bass, pike, catfish. Now walleye and catfish are eaten relatively often. Maybe not so much bass, but a lot of people in Wisconsin will be going to their Friday night fish fry and eating walleye and these higher predatory fish with large amounts of mercury, more than this, 1 meal per month. These are oceanic fish here, and what we see is things you shouldn't ever eat are sea bass, grouper, swordfish, tuna. Now this is for the women of childbearing age. Basically, women that want to have a baby shouldn't eat tuna steaks until after they've had babies, because it's too high in mercury for them, and they can have impacts on their future children. Other type of things that at least once a week or less. What do we eat? Nobody eats lobster more than once a week, but canned tuna might be in there. These are other things you can eat more commonly, but most people are eating probably this type of stuff: freshwater trout, mussels, salmon. Salmon are good, but some of the farmed salmon have too much mercury. So what happens if you have mercury? So the Mad Hatter, right, from Alice in Wonderland, it's a really interesting story where there was a term that said mad as a hatter, and that was someone who makes hats. A hatter was, someone who made hats. And what they did was they took mercury to preserve the beaver felt and the pelts, and they had a very specific way of acting, which was they were very shy, irritable, they didn't sleep, they were just weird people that tended to commit suicide, and it's because they were exposed to so much mercury over their life. They then had these weird tendencies, and that's where Lewis Carroll came up with the Mad Hatter as his character that acted very strangely. Same problems for wildlife. What does that look like in a narwhal? I don't know, but really the start of mercury poisoning, or where people really understood what it could do to people, was in Japan. So pre-World War II Japan and mid 20th century Japan, all of their protein was basically found from the ocean, right? Now we see a lot more beef and chicken and pork in the Japanese diet, but before it was completely pretty much from the ocean, because you're never far from the ocean when you're in Japan. So if you look in Minamata Bay, in the town of Minamata, there was a big chemical company, or I forget what the company made, but what they did was they dumped a bunch of mercury into the bay, and the local people, where did they get all of their food? From from the fish in that bay. And the first thing that people started noticing was cats around the fish markets were starting to act very, very strange, where they would do this weird dance and look, the cats were not acting normal. And it's because the cats would be eating, pretty much all of their diet would be from the fishermen would come in and then feed the cats with their, the parts of the fish that they didn't want, and those cats had almost 100% diet of large predatory fish. And but real quickly we realized this started happening to people too. And this is a picture of a person that has mercury poisoning, lots of birth defects. Over 2,000 people were affected, and there still are people to this day that are have to be under government care because of the problems in Minamata Bay, Japan, and that is not going away. So what I would say is this is really something, if you look at mercury deposition or mercury emissions, it's only going up, right? So the US is not building as much coal power plants, but worldwide we're very, very much increasing the amount of coal that we're using, and this mercury abundance is only increasing. So I would say in the future, please take a look at this, especially if you're a woman that wants to have children. Even if you're not sure if you want to have children, please try to abide by these things, and it will be very important for the health of your future children. I think one of the things that I want to talk about that has an interesting potential positive impact is physical structures that humans are putting into the ocean. What we see is that, sorry. Okay, there we go. The over 39% of the U.S. population lives in counties adjacent to the ocean, right? So these are adjacent counties to the ocean. Maybe in Alaska this is a little cheating, but because the counties are so big. But there's a huge amount of population that lives adjacent to the ocean, right? And when that happens, people don't want their shoreline to go away. So what does that mean? What they do is they armor the shoreline. If their shoreline starts to disappear, they put a bunch of cement and rocks down, and then that stabilizes the shoreline and they don't get their shoreline eroding anymore. So Florida in 1990, 21% of the Florida's coastline was armored. It's probably much higher now. The Mediterranean is 1,500 kilometers of it is armored. This is off of, I cannot think of the town in Dubai. There we go. Dubai in United Arab Emirates. Obviously, this is the world, right? So here's North America, South America, Africa, Europe, and Asia, right? They started off building these islands outside of along the shoreline, and it's just increased since then. And so, what is building these artificial structures in the systems, what are along the shorelines, what is that doing? Oftentimes what we see is it reflects, when you build a hard structure along a shoreline, it reflects, doesn't dissipate the wave energy. So if you go to Florida, the original habitat would be like hundreds of meters of beach, especially on the Gulf of Mexico side of Florida, where you would have 100 meters of beach maybe 200 meters of beach, before you would get to like upland area that is like, not overtopped by waves when you have storms. But think about it if you're building a hotel. You don't want to build your hotel 200 meters away from the beach or from the shoreline, from the water, because then the people in your hotel have to walk on the hot sand with their bare feet for 200 meters, right? So they build a hotel right along the edge of the water. And what happens? Well, a storm comes along and totally obliterates this beach, erodes it away. So they they armor it, and then their beach erodes away, and they're mad that their beach erodes away. So that's like the bad scenario of these artificial habitats. But a lot of artificial structures are actually okay, especially if they use natural material. So these pylons, right? They're being used here. You can see they're being used by aquatic life a whole lot. There's little intertidal zones. They're in their vertical structures. There's narrower intertidal bands there rather than a shallower sloping one. But it is still actually adding some habitat for these organisms. What we've seen is with oil rigs in the Gulf of Mexico, they've actually increased the hard corals that we find. Is that good? I don't know. But they're able to, like all of these shallow water and deep water rigs, they're increasing the whole coral biodiversity of the entire region. It's certainly creating genetic stepping stones for these organisms to potentially become invasive species in other ways. But generally we think of increased coral as a good thing. All right, let's then think about overfishing. So what we see is, it's not just with whales, but whales are a great example where we were trying to get whale oil, and we took the wildlife from the sea at rates that were too high for the species to replace themselves, such that now we really don't have very many whales left. Some whales are starting to come back, but it takes a really long time for whales to have babies. Now, this is also translating into fish species, right? People are eating fish at extremely high rates. We no longer have a viable Atlantic cod or Atlantic herring, and California sardines are pretty much all gone. We've seen these global depletions by the late 1900s. This is again that classic picture of those Atlantic cod stocks going way down. Basically what we see, right around the 1950s, there were a lot of people wanting fish protein. It's a good food source. It's available. It was available, I should say. So a lot of governments put in a lot of favorable policies and subsidies to get that fish protein to people. We generally think of omega-3 fatty acids as these good things that you can get from fish. And what we see is there's a lot of stocks of fish that are having problems in all parts of wherever we find our wherever we're getting our fish. So I would say, any of these fish, please do not eat. If you take a look at some of these, try to see if you have your favorite species. But why is this happening? And this is the idea of the tragedy of the commons, okay? If we have a shared resource, so an example of this is the toilet paper shortage that we have right now due to the coronavirus. I did not buy toilet paper, and now I only have like 3 rolls left in my house, but it's only because people were greedy and trying to get a whole bunch that other people now can't get any. We right now have enough fishing boats for 3 planets. Even though, so check out these fishing boats, right? They're huge numbers of fish, that nets that are miles and miles long. pulling out tons of fish with each sweep of that net. What we've done is reduced our fish populations to 10% of their pre-industrial population. So basically, 1900, since 1900, we now have only 10% of the fish that we used to. It takes about 17 times as much effort to catch a ton of fish than it did 100 years ago, right? And what's happening is our fisheries are really going to collapse based on our fishing rates within the next about 20 to 30 years. So what can you do? How can you find a fish that you want that's good? Well, do a little bit of research. Monterey Bay Aquarium Seafood Watch is a good place to start, where you can either look at a list or search for a species of fish that you want to do. And you can see, okay, should I be eating this fish before I buy it? Put it on your phone, bookmark it, and when you go to the market or you're at a restaurant, check that fish before you buy it. But what about aquaculture? Aquaculture is this huge industry that we're looking into more, as trying to find out of is that a good thing to do? What we're seeing is an increase in aquaculture, right? So we're some here, these are old data, right? A lot of the fish that you buy in a fish market or the grocery store right now are farmed, okay? And what we're meaning by aquaculture is generally these open pens that you find. There's a net on the bottom, right? But in the ocean, you're growing in these pens fish. And so check out on your fish. It'll either say wild caught, and generally wild caught, it's very easy to see that it's wild caught. If it's a farmed fish, it's pretty hard to find that thing. So if you don't see wild caught at the top of the label, it's an aquaculture fish. So the question is it a good thing, right? Is growing our fish in these pens a good thing versus going out and catching wild fish and depleting our populations? So the answer is I don't know. Let's look into it. So the when you think about it, so let's take a salmon. Okay, a salmon is sitting up here at maybe a tertiary consumer, right? You've got algae in the water, eaten by copepods, eaten by small fish, and then the salmon here. Okay, so whether you're sitting there at a wild-caught tertiary consumer salmon, or whether you're just farming it with these fish pellets, what you need to do is, they're still tertiary consumers, right? These fish pellets, these fish food pellets that they're feeding to these aquaculture pens are just ground up smaller fish, right? So these people here are just fishing for smaller fish that then they grind up and feed to them in their pens here. And so what do you see? Here's the guy, putting in that food, and these are insanely high numbers, extremely high densities of fish that what happens? All of these fish here they're not eating all of the food, right? And then all of their waste, all of their poop just collects at the bottom underneath those pens. So these fish then are also fed at higher rates. They can be more fatty, and they're lazy, right? They don't swim around very much. And so this is a wild-caught salmon, and this is a farmed salmon. And you can see there's very much differences. But if you actually go into now, most farmed salmon are not injected, but they feed them a dye, a red dye, so their meat is much more, it actually looks more red than wild-caught fish. So you can't always know because of the color. And then because these fish are so crowded, what you see is there's a lot of parasite problems. So the fish themselves are not as healthy. So I want to spend some time looking at Thailand, because Thailand has this really interesting story about how it has dealt with where it used to be catching a lot of fish, a lot of predatory fish that we would eat, like tuna, and now they're having to switch over to smaller fish. So what we see is most of Thailand's food is exported. And where does it go? Pretty much the United States and Japan. We're huge users of Thailand's fish products, seafood products, I should say. And most of that is shrimp. Okay, if you look at the U.S., where do we get our shrimp? This is shrimp imports from the United States, and it's mostly here, this purple, which is Thailand. Okay, Japan gets a decent amount from Thailand also. But the total amounts, right, we're getting a lot of our shrimp from Thailand. And if you look in Thailand, what we see is wild caught has really decreased in the last 15 years. Again, these data are actually getting pretty old here. Whereas aquaculture is starting to increase a lot. And what this is we're seeing an increase of the amount of food exported from Thailand, even though they have extremely, all their fisheries are extremely in peril. And what we see is around Thailand, there's some of the highest boat numbers. This is boat meters per kilometer squared, right? Because that takes into account the big boat being able to collect more fish at a faster rate than a small boat. But we see very high numbers. Here's Thailand right here, right? And what they're doing is catching really tiny fish. Their catch per unit effort has really gone down in the last 50, 60 years. And it's pretty much bottomed out. And so a lot of people, this is not really that profitable of an industry right now. As you can imagine, there's no fish out there. The fish they are collecting are just trash fish, small fish that we don't really use for anything other than grinding up and feeding them to shrimp. Combine that with Thailand's really low unemployment rate. Since they had a spike in that 2008, but realistically their that spike was up to 2.5%. They generally have unemployment rates less than 1%. And so who wants to work out on a fishing boat, catching these crappy fish that nobody really wants for relatively low wages? So what they actually do is get workers from neighboring countries. So if you compare how rich Thailand is compared to Laos, Cambodia, and Myanmar, or those are, people in Thailand are doing generally way better. So a lot of people are flooding to Thailand. And it's sad, but what we see is a lot of slavery actually on the fishing boats. So it was really interesting to me when I went to Thailand. I went in 2015, and I went on a liveaboard scuba diving, and it was really interesting because when we went into harbor, we were going out, right? And I saw all these fishing boats that were parked 200 meters, 300 meters offshore. And there were little dinghies that would then bring the fish catch onto shoreline. And I was like, why don't they just park their boats next to the dock? The more I looked into it, was finding that their boats were filled with slaves. And the average slave cost $420. And they that is how they're funding their fishing industry. It is obviously cheaper, and they're parked offshore, because if they were to pull up to the dock, the people would be able to run off the boats onto the dock and get away. And so what I would say is, as you're looking for your shrimp in the grocery store, if you go to Walmart, turn over that shrimp, pretty much 100% it's from Thailand. But if you go to better places, other grocery stores, pick American shrimp, because it's at least a little safer, and not going to be driven by slave labor. All right, so that is the rest of the ocean lectures. We'll come back thinking about wetlands and temporary wetlands here in the next couple lectures.